Hey guys, hope you're all doing well. So what we're going to be working with today is we're going to be working with parallel and perpendicular lines. But more so, before we get to the parallel and perpendicular lines, which you guys hopefully all understand what parallel is. I don't know if you guys have a good understanding yet of perpendicular. We're going to be working with slope, right? And a bunch of you, almost all of you have already seen slope or understood the concept of slope from previous classes. Slope applies to lines, right? So let's say we have a line like this, right? What a slope represents is the rate of change of a line, right? It's the rate of change of a line, right? And what that means is, again, it's how is that line changing? Is that line going up? Is that line going down? Is that line not changing at all? And when we're dealing with slope, again, it's analyzing, almost think of a hill, right? Whether the hill's being steep, where it's going up a lot, whether the hill is steep on the decline, it's always thinking about the steepness of a hill, right? So looking at this line, again, think of this as having a positive slope, right? And the reason that it would have a positive slope is because the line, and always go from left to right, almost as if you're reading, right? Has a positive slope because the line is going up, right? From left to right. So it's positive because the line's going up. If we had a line that looked like this, right? This would be a line that has a negative slope. And again, it has a negative slope just because the line from left to right, it's going down, right? So if you have a slope, slope always represents a number that tells you what the slope, what the line is doing, what a hill is doing, all of that. So if we had a slope, and typically we use the variable m, right? M is always used typically to represent slope, right? Slope, whenever you see it, you'll see the variable m. If we have a positive slope, we can say that something like m equals 5 would be representative of that slope. And we know that since the 5 is positive, the line's going up, right? Over here, since this one's going down and has a negative slope, all it is we'd be able to use a slope that's negative, right? And the reason that it's a negative for is because since the line's going down, the slope will be negative, right? Again, all m represents, it's always just slope, right? And slope is whether a line's going up, whether it's going down, how much it's actually changing. If we were to have a line that doesn't go up and down, right? Let's say that the line is just going, it doesn't, it's going up, right? If I had a line that was just going horizontally, right? It's not going up, it's not going down, then we would call that no slope, right? Basically, it doesn't have a slope. The slope of that would be, since something is not going up and it's not going down, the slope of that line would end up being 0, right? And the reason that the slope is 0, again, it's not going up, it's not going down, it doesn't have a positive or a negative slope like the other ones do. So always remember, slope is always just rate of change, right? It's whether a line is going up, whether a line is going down. If the line is going up from left to right, you would have a slope that's positive, right? If a line is going down from left to right, you would have a negative slope. And so again, all that's just helpful because whenever we analyze slope, and a bunch of you always remember slope is rise over run, right? It's how much it's going up and down, how much it's going across, right? But slopes tells us a lot because let's say if we had a slope that was 8, right? We know that that line is going up. And we know that the line's going up because, again, the slope is positive, right? If we had a slope that was, let's say, -2, we know that that slope is going down because it's a negative number, right? And again, these numbers here, what it tells you is the steepness of a line. So if you have a slope that's 12, let's say, it means that that line is increasing a lot. Almost the bigger the slope is, the harder it would be to climb up, right? Whereas if you have a smaller slope, let's say that you had a slope that was like -1, it means that the slope would be a lot easier to actually walk down, right? So always think, whenever it's a big number, it means it's changing quickly. If it's a small number, it means it's changing slowly. But again, positive slope means the lines go up, right? Up, up. If it's a negative slope, negative means the lines go down, right? And that's the idea of slope. right? Because now, there is something else that we keep working with slope and analyzing equations. It's something you guys have actually done previously, and it was called slope-intercept form, right? And it's something that all of you, I think, have done already before, and you guys have done well. Slope-intercept form. So when it comes to slope-intercept form, it's the form of an equation where we represent slope and we represent y-intercept, right? And that equation itself is y equals mx plus b, right? And now again, right now we know what m is, right? Whenever you see m, automatically we associate m with slope, right? So m right there, that's our slope. Then you have b, right? And what b represents is something called the y-intercept. It's called the y-intercept, and I'll show you what that means. So again, m is called our slope, b is called our y-intercept, and then x and y just represents any coordinate, because whenever we have a coordinate, it's always an x value and a y value, right? That's all x and y represents. So if we have a graph, let's say we had a graph right there. And on that graph, we had an equation. So let's say that the equation that we have looks something like, let's say it looks something like that, right? So before we do anything else, we automatically know right now that this line would have a positive slope, right? And it's a positive slope because the line's going up from left to right. And I'll even write the equation. Again, just making something up. Let's say it would be y equals 4x plus 2, right? So that's just an equation that would represent, and again, we'll go into that more. It's in slope-intercept form because it's y equals mx plus b, right? So what this represents is the lines going up and down. That's what our slope tells us. What this represents right, let me show you. What this represents right here, that would be what we call our y-intercept. And literally a y-intercept just tells you where that line always crosses the y-axis. Because on every single graph, it has the x-axis and it has the y-axis. And so literally a y-intercept tells you where the line crosses the y-axis, right? That's all a y-intercept is. So when you see an equation like y equals 4x plus 2, it's telling you that it crosses the equation, it crosses the y-axis at 2. That's what that positive 2 means. If it was a negative 2, it would tell you that it's crossing it down here at negative 2. But again, a y-intercept, it's just where the line crosses the y-axis. And in this case, it crosses at the number 2. So again, slope-intercept form, y equals mx plus b. Always remember, the slope is 4, it is in front of x, it's m. And the y-intercept is always a digit by itself. It's always a number by itself without a variable, right? In this case, always remember, m is the slope, b is the y-intercept. So if we were looking at this right here, we would know that 4 is our slope, it's m, and then the 2 would be our y-intercept and be our b. And again, we'll practice with this just so you guys actually see it. And again, it's important to be able to actually analyze it and know what it represents just by looking at it, right? So let's say that we had, and again, I'll write this just so you guys can see it. We have our slope-intercept form, y equals mx plus b, right? So let's say I have the equation y equals 6x plus 3, right? And I wanted to know two things. I wanted to know what the slope is, and I wanted to know what the y-intercept is. So if we're looking at the slope, we know that the slope is going to end up being 6. Because the slope is always what's in front of the x, right? Slope is always our m, always in front of x. So our slope is 6 in this case, and we know that our y-intercept, our b, is going to end up being 3. And we know it's a positive 3 because that's plus, right? So we know that our y-intercept is 3, which tells you, again, it crosses the y-axis at 3. And we know that our slope is positive, it's a positive 6. So we'd have a line that goes up, right? So that's how we always read it. Just always remember, slope is always in front of x, and then the y-intercept is always a digit that's by itself, right? So if I gave you an equation that looked like this, let's say y equals negative 5x minus 2. Let's say you had that now. Same thing. Let's say you wanted to figure out what the slope and the y-intercept is, right? In this case, we know that the slope, again, looking at everything, the slope's always in front of x, right? It's always our m, always in front of x. We know that our slope in this case is going to be -5. And always remember, slope is just a number. It's never a variable. So in this case, our slope is just -5, right? And since slope is negative, it tells you that the line's going to go down. And we know that our y-intercept, RB, is -2. Now be careful, because sometimes people are just going to write 2. Just always notice that there's a negative in front of 2, which means that the y-intercept is -2. So again, slope -5. Slope is always in front of x. And our y-intercept is -2, right? It's the digit always without a variable. And that's how we actually read slope-intercept and slope and y-intercept, I'm sorry. Now, let's say that I gave you slope and y-intercept, right? And I wanted you guys to write an equation. So let's say I told you right now that our slope was, let's say 5, and let's say our y-intercept was -7. If I wanted you guys to write an equation that represented it, again, it's just using the slope-intercept form, and we would write it. It would be y equals, we know that m is 5, so it would be 5x. And again, since b now is a -7, it'd be -7. And that would be our equation again, because all we did was just substitute. We know that m is 5, so we wrote 5x. And then we have b. b in this case is -7, so we put -7. Some people may want to write y equals 5x plus -7, which you could. But it's not necessary, because again, whenever you have that negative, it just means it's negative, right? Let's try it. Let's say that I had an equation where, let's say that I had an equation now where m was -4, and we know that slope was 8, right? And again, always just writing your equations, just taking everything into account, right? Whenever you write slope-intercept form, start with y equals, we know that m in this case is -4, so it would be -4x, right? And then we know that our b is 8. It's a +8, so we would write +8 plus 8. That's all it is, guys, whenever it comes to analyzing this. And if we look at them again, we know that 5 is positive, the slope is positive, so the line's going up. Over here, we know that the slope is -4, so it's going down. Always remember, if it's a positive slope, the line goes up. If it's a negative slope, the line goes down. That's how we actually use slope-intercept form to write equations, right? And now the last thing we actually got to see is we want to go into analyzing parallel and perpendicular lines, right? The slopes of parallel and perpendicular lines. Because it is the most important thing that you guys have a handle of the slopes of parallel and perpendicular lines. And the good thing is you guys actually understand parallel already. Perpendicular is the one that you guys may have a few issues with, right? So when it comes to parallel lines, all parallel lines are lines that are never going to cross, they're never going to intersect, right? We have this line right there, we have this line right there. Again, they're parallel, they're never going to touch. So we've also learned too that whenever you draw these arrows right there, it shows that those lines are parallel, right? The most important thing about parallel lines is if they're parallel, their slopes are always going to be the same, always. So it means if these two lines are parallel, if this slope is 3, this slope here is also going to be 3. Because the one way you guarantee that those lines are never going to touch is if their slopes are the same, because those lines are changing the same. So if this is going up by 3, then that one has to go up by 3, so they never meet. That's why their parallel lines always have the same slopes. So just remember, whenever it comes to parallel lines, slopes always must be the same. Slopes must always be congruent, always. Just because if they're not, they're never going to touch. If they're not, they will touch. So always remember, slopes are always equal, equal. always the same for parallel, right? So we have parallel, which is that slopes are always the same, right? Which means they're never going to touch. And then for perpendicular, that's the one that sometimes can cause a few issues, because when it comes to perpendicular lines, one is understanding what perpendicular lines are, right? So whenever it comes to perpendicular lines, there's two things that have to happen. So one, perpendicular lines, it means that one line is going to go up, right? And automatically the other one's going to go down. So right there, the biggest difference already between parallel and perpendicular lines is they cross, right? They're always going to cross perpendicular. But it's not just that they intersect. It's the fact that when they intersect, they make a 90-degree angle. That's what perpendicular means. It means that they will form a right angle every single time. And whenever you have a right angle, it means that it's 90 degrees. Now the reason that that right angle is so important is because whenever it's perpendicular, it tells you that the lines are straight. So if you have a 90-degree angle, it means that not only is this one going perfectly up, but that one's going perfectly across. The only way you can ever guarantee if those lines are straight is if there's a right angle. That's what that right angle represents. It means that those lines are perfectly straight, right? Now going back to this, the way that we know that lines are perpendicular is by analyzing their slopes again. So the difference is automatically we see that this line is going up. So let's give it a slope that's, and I'm just writing it this way just for you guys to actually be able to see it better. Let's say that the slope of that line is 2/5, right? Just making a number, which means it's rise over run. Again, it's going up 2, it's going across 5. If this slope is positive 2/5, what this slope here for this line is going to end up being negative because the line's going down, right? And it's going to be 5/2. So what happens when it's perpendicular? Not only are the signs different, one's positive, one's negative, but literally you take the reciprocal, which means whatever the number is, you're going to flip it over as a fraction. So the numerator becomes the denominator, and the denominator becomes the numerator, right? And that always happens because when it's perpendicular lines, again, they completely change. Whereas one's going perfectly up, the other one now is swapped over to go perfectly down to be straight, to make a 90-degree angle. So always remember, whenever it comes to perpendicular lines, and this is always the hardest one, slopes must be opposite reciprocals. And again, what that means, opposite reciprocals, and just always be careful of it. Opposite reciprocals means that, opposite means that signs are going to be opposite, one's positive, one's negative, and the reciprocal just means that we literally swapped the fraction, right? Instead of being 2/5, it becomes 5/2. That's what it means to be opposite reciprocal. So whenever it's perpendicular, the fractions have to be opposite reciprocal. The slopes have to be opposite reciprocal. It's usually the hardest one to understand, but again, the easiest one is always parallel, because when it's parallel, the slopes literally stay exactly the same. And why that's so important is, again, let's say we have this slope over here, right? Let's say that this slope was 7, and this slope was 7. Automatically, we know that those lines are parallel, right? Just because, again, slopes are exactly the same. Same thing. If I had, let's say, -3, and we had -3, it means that those are also parallel, right? Because, same thing, slopes are exactly the same. Now, if we had something like this, where m is, let's say that m is 3/5, and then m is -5/3, that would be perpendicular. This one here would be perpendicular. And that one there would be perpendicular just for the reason that, again, you have opposite signs, right? One's positive, one's negative. Instead of being 3/5, it becomes 5/3. That's what it means to be perpendicular, to have an opposite reciprocal, guys. And if it's not an opposite reciprocal, so let's say you had something like this, where m is 2/3, and then m is 3/2. Sometimes people would think that this is perpendicular, but it's not perpendicular, because even though we have a reciprocal, 2/3 and 3/2, they're both positive, which means those lines are going up, both of them. And if they're both going up, it's impossible to ever be perpendicular. One needs to go up, one needs to go down. So in this case, it would be a situation where it's neither. Because even though the slopes are reciprocals, 2 over 3 becomes 3 over 2, they're both positive. So always be careful with that. And the last thing I want to show you guys is just knowing. So let's say I had 2 equations, right? Let's say that I had the equation y equals 4x minus 7, and I had the equation y equals 4x plus 12, right? And I wanted to know whether this is parallel or perpendicular. All you ever care about is just the slope, right? So if I look at this first equation, I say that the slope is 4, right? In this equation, I said the slope is 4, because again, slope is always in front of x. Whenever we want to know whether lines are parallel or perpendicular, you just look at the slope. And in this case, both slopes are the same, so it would be parallel, right? And it's parallel lines because again, slopes are exactly the same. Now, if I were to look at an equation that looks like this, let's say I had 2 equations, one where it's 3 over 7x minus 12, and then I had another equation where it was negative 7 over 3x plus 4. Again, whenever you want to analyze whether lines are parallel, perpendicular, or neither, look at the slopes again, right? In this one, we know that the slope is 3 over 7. Over here, we say that the slope here is negative 7 over 3. So again, one's positive, one's negative. And instead of being 3 over 7, it becomes 7 over 3. Opposite reciprocal. Since it's opposite reciprocal, it's perpendicular. Just always keep that in the back of your mind, guys. And again, the easiest one to always see is parallel. But when it's perpendicular, always realize they have to be opposite signs. And it has to be reciprocal. And we never care about any of the other numbers. We never care about the y-intercepts. Whenever it comes to analyzing whether it's parallel or perpendicular, always look at just the slope. Always look at what's in front of x, guys. Again, any questions, feel free to ask.